Elon Musk has officially set the stage for Tesla's most disruptive move yet. The 2026 Model 2 is no longer a concept or future promise. It's real, and it's reshaping expectations for what an affordable EV can deliver. Musk has openly signaled confidence, pairing ambitious design with accessibility, and Tesla's engineering team has implemented 7 groundbreaking updates that redefine what a car at this price can achieve. Production lines are being retooled, supply chains optimized, and manufacturing processes upgraded to bring this next-generation vehicle to life. The Model 2 merges high-end driving DNA with a budget-friendly package, proving that cost doesn't have to mean compromise. It draws inspiration from the precision of a Porsche 911 and the poise of the Jaguar F-Type, achieving driving dynamics that feel familiar yet entirely new. Tesla's engineers call this scale dynamics, applying the low polar moment concept of the 911 and the longitudinal aesthetic of the F-Type to a compact car. By reducing rotational inertia by 10 to 15% relative to class, the Model 2 maintains lively steering without the instability typical of sports sedans. Weight distribution is key, with a slightly rear-biased front-to-rear split of about 48 to 52%. Battery modules were positioned rearward, and front subframe mass was tuned with approximately 55 pounds of ballast and structural elements, optimizing rotation through corners. The wheelbase is longer than typical compacts by 6 to 12 inches, smoothing highway rides, while short overhangs retain maneuverability in urban environments. Suspension blends Porsche-inspired anti-roll geometry with Jaguar-style multi-link comfort tuning, lowering spring rates roughly 15% from a pure sport setup, while stiffening anti-roll bars by 10%. The result is taut yet forgiving handling, smoothing harsh city streets while delivering confident highway stability. Steering is 10% quicker than average compacts, tempered with software damping to prevent twitchiness. Aerodynamics are carefully balanced, targeting a drag coefficient of 0.22 to 0.24, with subtle lift control for high-speed stability. This improves energy efficiency, adding 8 to 12 miles of range on a nominal 250-mile vehicle. Interiors follow Jaguar's tactile hierarchy, using selective molded foam and thin leather alternatives to evoke premium feel at minimal material cost. Tesla studied the sensations drivers associate with high-end cars and recreated them from the ground up, tuning every curve and weight distribution for emotional resonance, not imitation. A standout innovation is the Model 2's Falcon Wing doors, a feature traditionally reserved for far more expensive vehicles. These doors provide practical advantages in narrow spaces, for older passengers and in inclement weather, while remaining affordable. Tesla simplified the complex multi-axis motorized system of the Model X into a hybrid mechanical counterbalance assisted by a single motor and over-center dampers inspired by aviation door tech. Motor torque requirements dropped by 60%, parts counts by 40%, and component costs fall 30 to 45% per door. Weight is managed carefully, keeping doors within 26 to 40 pounds, preserving handling and center of gravity targets. Aperture height improves access, and rain management prevents intrusion under highway conditions. Standardized actuators across models reduce maintenance costs, a boon for long-term ownership. Tesla addressed structural integrity with advanced gigacasting. Early prototypes showed stiffness anomalies and vibrations above 65 miles per hour. Engineers solved this through strict alloy chemistry, vacuum-assisted die casting, directional solidification, post-cast homogenization, and precise heat treatment. Alloy tolerances of plus or minus 0.5% prevent stiffness variation. Directional solidification and vacuum pouring reduce trapped air and shrinkage voids, minimizing high-frequency resonance. Post-cast treatments normalize grain size, relieve internal stress, and constrain key surface deviations to 0.020 inches. Targeted reinforcement in 10 to 20% of the underbody preserves weight savings while ensuring uniform stiffness. Elastomer isolators and tuned mass dampers cut perceptible vibrations by 70%, eliminating the shivers often felt at highway speeds. Each casting is scanned ultrasonically and thermally, maintaining defect rates under 1 per 10,000 parts compared to 1 in 500 in traditional stamped assemblies. The Model 2 enhances usability and long-term savings through intelligent systems. Pothole Guard detects road irregularities via cameras and wheel sensors, adjusting damper stiffness within milliseconds to reduce vertical acceleration, tire strain, and alloy rim damage. Storm Vision keeps cameras clear in rain and fog using nanohydrophobic coatings, microheaters, and air jets, improving driver assist reliability with minimal energy use. Integrated charging embeds power management and communication directly in the inlet, eliminating adapters and accelerating charging protocol recognition. Peak power reaches 200 to 250 kilowatts, reducing charging time by 10 to 14% on long trips. Predictive wear pack monitors tires and brakes through localized sensors, identifying uneven wear and pad thickness before damage occurs, reducing repair costs and consolidating service visits. Onboard service mode guides users in independent garages with step-by-step instructions, torque specifications, and fault translations, cutting labor time 20 to 40% while preserving safety and warranty integrity. Ultra-wideband key authentication prevents relay attacks, while mesh recovery allows nearby Tesla vehicles to assist in locating lost or stolen cars. Coro shield and drainage systems combat rust and corrosion, extending lifespan even in harsh climates. In sum, the 2026 Model 2 demonstrates that affordability, performance, and practicality can coexist. Its chassis dynamics, manufacturing sophistication, and intelligent systems show that cost-efficient vehicles can deliver high-end experiences without compromise. Every detail, from suspension tuning and aerodynamics to door mechanics, structural integrity, and predictive maintenance, is engineered to maximize driving enjoyment, safety, and long-term value. Tesla has redefined what a budget EV can be. Exhilarating, practical, durable, and smart, setting a new benchmark for the electric vehicle industry and proving that innovation does not have to wait for a luxury price tag, some. The Tesla Model 2 redefines the notion of an affordable, high-performance electric vehicle. From precise chassis dynamics and advanced manufacturing techniques to innovative features that reduce maintenance costs and improve everyday usability, Tesla's approach demonstrates that a budget-friendly EV need not compromise on driving pleasure, safety, or long-term ownership value. The integration of sophisticated suspension tuning, aerodynamic optimization, smart materials, and sensor-driven systems illustrates a level of engineering thoughtfulness previously reserved for high-end vehicles. By addressing real-world challenges, such as potholes, adverse weather, and limited garage space, the Model 2 ensures that practical usability complements exhilarating driving dynamics. With cost-effective yet premium-feeling doors, ultra-secure keyless entry, predictive maintenance, and rapid, adapter-free charging, Tesla has proven that innovation can thrive even at the lowest end of the price. The message Elon Musk delivered couldn't have been clearer. Not maybe, not possibly. This change will happen. The Tesla Pi phone has arrived at just $175, and this time it goes far beyond normal smartphones by eliminating carrier fees entirely through lifetime Starlink calling and satellite internet, even in the most remote American regions. Its new oxide-based display architecture, quietly referred to as Rule Rewriting Glass, pushes durability into a new category, while its built-in communication hardware is already aligned for future Martian networks, making it the first device intentionally engineered for use both on Earth and beyond. The question now is whether Apple can realistically match any of this. This analysis breaks the entire story down by examining 3 breakthroughs with technical clarity you won't get from headlines. If real American-made engineering matters to you, subscribe and help us reach 239,759 supporters. We begin with the core issue: how unlimited, always available Starlink connectivity can actually replace conventional cellular service, especially for seniors. The promise of never paying for another phone plan and never losing access